we talk about the OOPS concepts. These are basically OOPS concepts: abstraction, encapsulation, polymorphism, inheritance, aggregation, and message passing. So one object can pass messages to another object. So these features we use with the object-oriented programming. So Java also uses these object-oriented programming features. C# uses, Ruby uses, then C++ uses these OOPS features. But you find minor differences in implementing them. So Ruby and Java, they are similar. To some extent, C# and C++ are similar. Because in the C++, we have multiple inheritance, multi-level inheritance, single inheritance, hybrid inheritance. Similarly, it has operator overloading feature, but in Java, we don't have multiple inheritance. There is no operator overloading. It's only single inheritance we use. Interfaces concepts you find with the C++, you find with C#, you find with the Java. To take the C++ features of a few features C++, if you take, you find them in the C#, like operator overloading. So this way, we have some similarities among the languages, but all of them basically object-oriented programming languages. So you create, first of all, specification for the object, then using the specification you create an object, then after that you invoke methods against the object, so data of the object can be getting processed. Whenever you specify an object, normally the data of the object, you make it as private data. With the help of the public methods, we access data, we manipulate. Like this we have here encapsulation and protection for data. So using allowed methods only, you can be processing data within the object. So that is basically the object-oriented programming. So with that, what happens? You can delegate certain work to certain class only, certain object. The object is responsible for all such, data processing activities given to it. Like this, delegation of work you can achieve with the help of the object-oriented programming. Just like an office, in the office you have different types of personnel there, different people are there. A particular person, if you take, he is assigned actually particular type of task. If you take some other person, that person has been assigned some particular type of task. So the whatever task is assigned to person, the person should be doing it. Nobody else can do that particular thing. So same way we can do with the object-oriented programming. No two classes should be performing same kind of operation. Then there is no meaning in making classes. If when you create a class, it should be having some special type of functionality it should be doing there. Some specific functionality it has to do. So when you create an object class, so no two classes should be similar. There should be some minor difference at least. Like that you have to classify. The programming features you have to classify with the help of the classes. So classes contain methods. Methods are basically code repositories or code blocks. They can be performing some actions. So actions cannot be existing independently. In the form of methods only, they are available with the Java classes. So the methods are going to be here action performers, I can say. They perform some action. So therefore, in the code, in the method only you write the required code. So let us start working with the object-oriented features in the Java now. First of all, let me make a very basic class. The class can be called as here point class. Point is a geometry term we use. So when you take geometry that contains the planes and spaces. So in the plane, a tiny object you can call as a point. A point is a dot or very small particle we can say which is lying in the given plane. That you can say as a point. But how do we describe a point? Using a coordinate x and y, using two coordinates x and y coordinate, we can represent the given point. Similarly, in which quadrant the point is lying, you can identify with the help of the x value as well as y value. Similarly, you can move a point from one location to another location. So using move point. So therefore, like this here, you can manipulate the points. Even when you take a line, it's nothing but set of points only. So point is the primitive geometry. So further that cannot be broken down. When you take point further cannot be broken down. So therefore, point is a very basic thing in the geometry. Therefore, we start with the point. So when you look at point, how we describe point with the help of x coordinate, with the help of y coordinate. They are therefore x and y are going to be data. If you don't have any data, there is no meaning for the object. So object meaning is what some kind of state is required. Some state is required. Without state, there is no meaning for the object. Therefore, when you look at point, the point contains here x coordinate as well as y coordinate. We have both coordinates x and y. Based on that, we can instantiate the given point object. You can make n number of point objects, but no two points may be same. Of course, they can be same, one can overlay on the other, but normally they should be different. So for some point x equal to 0, y equal to 0, so for other x equal to 0, y equal to 1, for other x equal to 0, y equal to 2. So like this, you can get new points also. So the different points have different states. So they can be called as objects, but basically they belong to point class. A point is nothing but specification for the object. So point class is nothing but specification for the point object. Using that specification, we can be creating point object. Just like int, you may have int. Int is what? It's nothing but a specification. That means what? It's integer data. It requires 4 bytes of space. It can contain a maximum integer value, minimum integer value. So then followed by, you can perform certain operations like addition, multiplication, then division, subtraction, then remainder, you can perform on those. They are the operations. So like that, the type has been defined integer. So int is what? It's a specification. It's called as type, or we can say data type. But this is what here, primitive type. When you look at point, a point is what? You created it. This is called as here user defined type, or you can say it as a ADT, abstract data type. So data is totally hidden in this. It should be in fact hidden. So when you hide here, you have internally x coordinate, y coordinate, and you have few methods for that. So like this, you can define a point. You put on the top class point here. Using a class keyword, a class can be defined. Within this point class now, we define like this: private int x, similarly private int y. So these are referring here x as well as y coordinates. X coordinate, y coordinate, you have two coordinates here. You have private int x, private int y, followed by you require a constructor here. Constructor can be here public, followed by here it is point. We specify like this. This is called as here a constructor. Here you can initialize the fields. X and y are nothing but fields here. X equal to, you can put some value like 0, and y equal to 0 you can put. This is called as here default constructor. It takes same name as the class name. You can look at this. Class point it is, and here also it takes same name as the class name. And it does not return any value. This is what? It's a method. A constructor is nothing but a method. Methods normally return a value. When they don't return a value, at least you have to mark them as void. Void meaning is they do not return any data. Like that, you have to put void before the method name. But here, in the case of constructor, which is a special method, you never put any void there. You don't put any void, so it's public point, the class name it takes. In the case of point, it takes point here. If it's a circle class, you put a circle here, it can be circle. So like this, you can have here a constructor. Next thing is going to be here, public, one more constructor I put here, public point here, then write int xc and int yc I put here. X coordinate as well as y coordinate I can set. So here I write x equal to xc and y equal to yc. Like this I can put it. So this is what exactly? It is a constructor again, but with parameters. First one is a constructor without any parameters. Second one is a constructor with parameters. This is called as here a default constructor, and this one is what here? It's a parameterized constructor. Now this feature is called as here overloading. Overloading meaning is what here? You have the same method name, but list of parameters change here. List of parameters when they change, this feature is called as overloading. And this is what here, constructor overloading or method overloading. Since constructor is also a type of method, we can call this as method overloading here. Constructor is a one special type of method which does not return any value. A constructor does not return any value. They take same name as a class name. They are going to use same name as a class name. Then followed by here, you can have parameters or you don't have parameters. When you don't have any parameter, it's called as default constructor. We call that as default constructor. But in the case of this public point int xc, int yc, this method is called as a parameterized method, and we call this as a parameterized constructor. A constructor with parameters, constructor without parameters. So like this, we make the class here. Class point we make a point class without any say arguments, and you have another class called as point with parameters. In the first case, you don't have any parameters. In the second case, you have parameters xc and yc. So like this, here we created two different constructors. A point constructor without parameters, another constructor with parameters. So like this, here you have two constructors. A point which does not have any, which does not have any parameters. In the second case, we have a point class with parameters xc and yc. So like this, here we have a point class. The point class is containing here data, private data, x and y, and you have two constructors, point without parameters, second one is point constructor with parameters. Like this, we have defined here a point class. Now come to next one. Here in this, now you need to manipulate the point. Manipulation meaning is what? With point, what we can do? We can find out first thing in which quadrant point is lying. You can find out. Second thing is what here? You can move the point from one location to another location. Apart from that, you can't do anything. Apart from that, we cannot do anything. So therefore, here in this, you can perform only one operation here. Two operations you can perform. One is what? Finding out in which quadrant the point is. And one more thing is what? You can, you can go with the movement of point from one location to another location. You can move the point. So like that, you can be making here points, point methods, point related methods. You have the move point. One more thing is what there? You have here, other thing is like find quadrant. In what quadrant the point is lying, you need to find out there. Quadrant can be first quadrant, second quadrant, third quadrant, fourth quadrant. So that we implement with the help of the enumeration. Using enum, we implement. So like this is called as a class. A class can be having a scope of public or it can be having a default scope. There are only two possibilities as far as class is concerned. In the case of class, it can be public class or it can be default class. A default class is available within the package anywhere. The scope for the class is what here? You have a default class and other one is you have a public class scope. So in the case of public class, it is available within the same package. When you go outside the package, the class will not be available. But when you make a class public, it can be available even in other packages. If you refer the package with proper naming convention with the help of the import, when you refer, in such cases, this class will be available. But private packages, private classes will not be available for us like that. Not private, default. So default classes will not be available. But public classes, they are going to be available. By default, these can be called as default scope. That means within the same package, anywhere you can use it. Any questions on this, please? Bengal, you have any questions?
Hello?
Yes, Bengal.
Yeah, Sridhar. I don't have any questions.
So, like this, the data is going to be private and constructors, they take same name as a class name. They don't return any value. They can be without parameters or they can be with parameters. Apart from that, we can define methods. Now, let us try to make a class. Point class, let us try to make by starting a new application here. And one more thing, I have shared yesterday a few applications with you. Have you got them? I have shared a zip file with you. yesterday. You can download and you can unzip that. You can look in the programs. I have shared few programs with you related to this Java. Around 31 programs I have shared with you. Not these actually. These today I am going to share, but some other programs I have shared with you. Okay, so now let us make in this a new project. Here it is. Java. We write. Then let us finish and create a class now. This is point manipulation is going to be the program name. This is containing here a class called as point manipulation, which is containing here main method. But we haven't defined any class in this. In the same package, we can be defining in the same file also, we can be defining it. Here, we can define now another class called as a point class. But in the given file, you cannot have more than one public class. In one physical file, you have to have only one public class. You cannot have more than one public class in the physical file. The physical file name is what here? It is going to be point manipulation. The file name is going to be. So here you should have only one public class. You cannot have more than one public class. If you want to make another public class, therefore open one more file. In that file, try to manipulate. So now this is called class point we make. Then inside this, we define the data. Put it as here private. Then followed by put it as here int xc, x coordinate. Similarly, private here, put private here, int yc. So when you mark the data as private, what happens? The scope is limited to only this class. This class's members only they can access this particular type of data. This data xc and yc is not available beyond the scope of the point class. Within the point class, you can access anywhere by any method. You can be accessing it. But as far as some external classes are concerned, that cannot straight away access x and yc, xc and yc, they can't access because these are totally hidden. They are part of the just point class. Within the point class, any member they can access. But outside the scope of the point, no one can access it. No one can be accessing. So therefore, this is called as here private data. Private int xc, private int yc. So xc and yc are going to be here the coordinates. So they are internal to the point class. Using some other methods, you can be accessing xc as well as yc. Okay, so you cannot, straight away manipulate these from outside the scope of the class since we marked it as private. These are what therefore private fields we can say are private member data. When you take a class, there are two different things in that. One is member data, other one is methods. So here xc and yc are what exactly? These are going to be members. It is called as here member data. Xc is member data, yc is also going to be here member data. This is called as member data, xc as well as yc. So you have here two different type of data. One is xc, other one is going to be yc for us. Now let us create a constructor here. Put like this, public followed by, we put it point, then we take the parameter like this, and inside this we can write xc equal to 0, then yc equal to, it is here 0. Like this we can instantiate it. So when you put here xc and yc equal to 0, the point is located in the origin. Exactly at the origin, the point is located now. Origin is nothing but intersection of both x and y coordinates. Therefore, at that point, at that location, we have 0, 0. Therefore, point is located in that area. Now let us create one more parameter, which is called as one more constructor, which is called as parameterized constructor here. public, then followed by here point, we put like this, then right here int x, int y, we put like this. Okay, now in this, here I make xc equal to x and yc equal to y, I can put this way. This is what exactly? A constructor with parameters. This is a constructor with parameters. This one is called as a parameterized constructor. First one is called without parameters, second one is with parameters, we made it. Now let us write here one more method. What the method here in this is? Public, then write here void, then here write move point. We put like this a method called as move point, then here we specify int x, int y. We give here new coordinates, to that coordinates we have to move it. So move meaning is what? Changing the existing coordinates, x equal to x and y equal to yc, yc equal to, we can put it as here y. Like this we can put it. It's not cx, xc equal to x, y is equal to y. Like this we can specify the coordinates. Move point int x, int y. We are moving x into xc, y into yc. Like this we made here move point method. This is fine. Now one more method we require. With the help of that we have to identify in which quadrant exactly the point is lying. So for that purpose I can use some enum here. Therefore let me define here an enum. This way here. Declare enum quadrant. I can put like this here quadrant enum. Inside this I can put here first quadrant, then followed by second, then this is here third, and next thing is here fourth. Like this I can define here a quadrant. I have defined the quadrant as first quadrant, second quadrant, third quadrant, fourth quadrant. This is called as enumeration. You can have more than one constant in this. There are four constants. First equal to 0, second equal to 1, third equal to 2, fourth equal to 3. Like this we can be getting the enum here. So you have here total 4 quadrants. Quadrants are how many? You have only 4 quadrants possibilities there. So first, second, third and fourth. In such cases you can define constants. So using quadrant dot for either first or second or third or fourth, you can be accessing it. Now let me write here method. In this method, what I do, put like this here public, then this is quadrant I write, followed by get quadrant I write here. Get quadrant I can put here. This is going to be the name of the method. Okay, this is what the method name is here, get quadrant. And this one now is going to be containing data. So here write quadrant QRD, this equal to, we put it as, write it as quadrant, then dot first. You can take, by default you can take it as first quadrant. This is what exactly the first quadrant, we kept it. Return, we put here QRD. So we put here return QRD. Now after this I want to find out in which quadrant exactly it is lying. By default I assume it is the first quadrant. The condition for second quadrant is what here? We can use if condition. If x is less than 0, in such cases what we write? We can use like this. If x is less than xc, x coordinate is less than 0, in such cases we can find out like this. Another if condition also we can use here. If yc greater than or equal to 0, in such cases QRD equal to, you can put it as quadrant dot, this is what second we use. Else we write it as Q or D equal to quadrant dot, this is third, we can put, we get like this. So else what we can write here, if xc is less than 0, so if x is less than 0, therefore what we put here, if x is less than 0, if y is greater than 0, QRD equal to quadrant dot second, else quadrant equal to quadrant dot third. We have written like this. Else, if x is greater than 0, then in such cases can we write straight away y coordinate? You cannot put that. Reason, the possibility is what? It can be even in the third quadrant. So therefore here write, if condition, if yc is less than say 0, in such cases we can be writing q or d equal to quadrant dot, this is here fourth. Like this we can be using. So this way we can find out in which quadrant it is lying. With the help of this get quadrant we can find out there. When x is less than 0, in such cases we compare there. What we compare? Yc greater than or equal to 0, then write q or d equal to quadrant dot second, else quadrant dot third. When both xc and yc less than 0, it means what? They are in the third quadrant. Suppose x is not greater than 0, less than 0, that may be equal or that may be greater than 0. In such cases we check for the yc. If y coordinate is less than 0, it is going to be the fourth quadrant, then ultimately we return. So this is the logic we are using with the get quadrant method. Using get quadrant method in this manner we are trying to write it. Now come to here the main method. In the main method let us try to manipulate it. So what do we write here in this? We can create now a point class. We can create a point class in this. Write like this, point, then object p equal to, here it is new point we can put. I created with the default constructor. I created object point. Now let me find out here let me find out the quadrant for it, because you can do only moving point, other one is finding the quadrant there. So here system.out.println, write in this x equal to, you cannot print individually anything here. You can't print anything individually. What are the values in the x and y also you cannot print. So here write the point is lying in quadrant. We put plus here followed by object p dot, you can say get quadrant. This can be returning for us quadrant, that you can convert to string. You can convert to string also. Like this let us try to print here. So this can give you the quadrant of the given x and y coordinate. I mean the quadrant of the point it can give. So it is going to take the x and y. With the help of that it can find out in which quadrant it is lying for us. Now next thing, I move the point, object p dot move point. So here in this I can be changing the values now. Make it 10 followed by minus 20. So this time it should say the point is lying in the fourth quadrant. See what do we get? You can see in this. Okay, now try to run this. What it's saying for us, the point is lying in quadrant first, the point is lying in quadrant 4. Like this appropriately it's printing for us. In the first case it is saying the point is lying in the first quadrant. In the second case it is saying point is lying in the fourth quadrant. Reason, y is negative, x is positive. In the first case both are 0, so therefore they fall in the first quadrant. So like that it's giving you the first and the fourth quadrant in this. So with the help of enum we are doing. So What is enum exactly? Enum is nothing but user defined scalar type of data. I have defined the type of data. It's containing 4 constants. First value, second value, third value and fourth value. I have 4 constants. So I can use them like first, second, third and fourth. So quadrant dot first is giving you 0, quadrant dot second can give you 1, quadrant dot third can give you 2, quadrant dot fourth can give you 3. So like that you have integer constants first, second, third and fourth. So this is what user defined type of data, which is nothing but scalar data. It's not aggregate data, it's scalar data. So like this we created, and using here we created point object, then we initialize it with a 0 0 initially, because default constructor is initializing with 0 0 only. Then it prints there in the first quadrant. Then we have move point. When we move point, what is happening? You are getting 10 comma minus 20. So with that it's printing this way in the fourth quadrant. But when you look at this, the point class, suppose you want to print x value and y value. Do you have any provision for that? Right now you don't have any provision for that. If you look at the point class, xc, yc, they are private. You can't access them from the point object. Point dot, you cannot access that. Let us try to see whether it's possible or not. See right here, system dot, then out dot println. Put here object p, then dot, try to use x. Nowhere x is available. xc, is it available for us? It's not available. Suppose you want to find out x coordinate and y coordinate, you can't find out there. We initialize it, we are writing inside, but you can't access the data. How to access this data? Or if you want to modify xc and yc, right now you have move point, with that only you should do it. Okay. So 2 parameters you have to pass, but you want to change only xc. In that case, you don't have any provision. So you need to write those methods also with the help of the set and get. Using set and get, you have to do. Similarly, if you take the object point, here come to this. If you use here something like system dot out dot println, if you try to put here object p dot toString, suppose I put toString in this, what do I get with that? Let us see in this. It is giving some senseless information for us. You can't understand anything from this. Point at the rate 6.90 E0 BFD, something it's printing. So in no way that is meaningful. So you must override the toString. When you override x equal to y equal to, you can print. Because the toString is defined with the object class. On the top of the hierarchy, you have a class called as object. From there only all these are getting inherited. From object class, they are getting inherited. So therefore, you have to override toString method which has been defined in the object class. Therefore, come to here point class and try to here define it. Override that particular thing. That concept is called as overriding. Override meaning is what? In the base class, you have certain method. That method as it is you are going to implement. You don't change parameters, you don't change return type, but code you are going to change internally. That feature is called as overriding feature. So let us try to override it. Here write public, followed by string it is, then followed by this is toString. We convert it to string. But what should be converted in this? That is important. So right here, return x equal to plus xc, then write plus y equal to yc, we put like this. Yc equal to plus yc we put. Let us try to return like that. What we are doing here? So x equal to plus xc, y equal to plus yc, we are printing like this. This is going to be the coordinates, values for coordinates. Okay, then right here, put here, and it is lying in put like this plus write get quadrant, then dot toString you can put here. So like this we can be displaying information. Now if you try to run this, what it prints, see here. So now when without before I write that code, it was printing 0.8659 E0 BFD. So some data is being written there in that case. But when I overridden here, it's going to print these values. You have arrow mark, see what it says, it's overriding. This is overriding the object class. In the java.lang.object, we have a class called object there. That in the object class, we have a toString method that is being overridden here. It's overriding here in this. Try to run now here in this. Now it says the point is lying in quadrant first, the point is lying in quadrant fourth. After that, values for coordinates x equal to 10, y equal to -20, and it's lying in fourth quadrant. So like this here we have overridden the toString method. We have overridden toString method within the point class. Any questions on this, please? Okay. So this is what we have created a point class, then we are printing its quadrant. In which quadrant point is lying, we have printed there. Now let me write two more methods. With the help of that, we can modify both x as well as y. We can modify there. After these constructors, let me define that. Here write public followed by void, then write here set x. Then this is int x. So here x equal to x, let us put. Then write here public, then void set y. This is what int y here. Then write here yc equal to y. This way we can be setting x coordinate as well as y coordinate. Now with the help of this you can be setting, but if you want to retrieve, you have to write get methods also in that. Write here public, then this is int, get x we can write. So with this what we do, we can be returning x coordinate. Write here return xc. In the same manner, we can be returning y coordinate also. Take this, try to return here a y coordinate. Put like this here, get y we use. With this, we can be returning here y coordinate. Write it as here yc. So therefore, here we have written important methods in this. The first one is what? It is going to be a point class. X is a property, YC is a property. Property in the sense here it is a field. So inside the object, these values are required. X coordinate, Y coordinate are required. Without that, you can't do anything. Okay. So here private int XC, private int YC. Like this you have here X coordinate as well as Y coordinate. Okay. So next thing is what here? We have two constructors, a point constructor without parameters, second one is with parameters. Then we have here set x, set y methods. With the help of that, we can be assigning x value and y value. And with the help of get x and get y, we can be retrieving values for x as well as y. And with the help of move point, we can be moving point from one location to another location. And with the help of get quadrant, what we do, we are finding out the quadrant, in which quadrant it is lying, you can find out. Similarly, with the help of the toString, we are printing the object as it is. So what is the state of the object for us? X coordinate, Y coordinate, and where it is lying, that is required. So this way we have printed here the members of the point here. So this is toString we have overridden. This concept is called as overriding. The base class, object class, from object class we have taken this method and once again we define. So that feature is called as here overriding or altering methods. We have altered it. We replaced as well as we altered here. It can be called as replacing as well as it can be called as here altering. We altered as well as we replaced here the code. Altered means small modifications you can make, but in the case of replace, entire code can be changed. So like that you have alter as well as replace words. That is with the overriding feature. So here we have overridden, but with the constructors what we have done, we overloaded. That feature is called as overloading and this feature is called as overriding, and this works with the runtime polymorphism. Overriding feature works with the runtime polymorphism, whereas overloading is going to be compile time. So before you invoke the program, before you execute program, you know what methods have to be bounded. So that is what exactly a compile time polymorphism. But in the runtime, it can be changing. You may call object or you may call this particular thing. So therefore, this is called as here runtime polymorphism. We can call this as runtime polymorphism. So you have two polymorphisms. One is compile time, other one is going to be runtime. So runtime polymorphism is called as late binding. We can say lazy binding. Compile time polymorphism is called as early binding as well as static binding. So in the case of this runtime polymorphism, dynamic binding we say, lazy binding we say, late binding also we can say. The methods are bounded. In the runtime, somewhat slow they are when compared with the compile time or static time binding. Any questions on this, please? Okay, so here we created a point class, then we have written like this. So this is what it is, creating constructors, then similarly writing private data, then followed by using setx, setY methods, getx, getY methods. These are called as actually getters and setters. With the help of setx you are setting value, with the help of getx you are getting x value. So setters and getters we have, set methods, get method we have written here. Then with the help of move point method we are moving the coordinates, and then you take the quadrant, get quadrant, you can get the quadrant of the given point. And in the case of toString, what is happening, we are converting the value of the point into string. So like this it is going to be working with us. So this is here we call as ADT, abstract data type. Now further, suppose you want to extend this into another class. So what another class you can form with a point? How you can extend a point to something else? I can write like this, a new class called as color point or 3D point I can put here. I can put like this here, 3D point. So let me put here 3D point class, I can write it point 3D. I can make a class called as here point 3D. I want to make like this. What is the meaning of point 3D in this? Point 3D is going to be extending. Extends what class exactly? It's going to extend the point class. Extends this one exactly, point. This feature is called as now inheritance. Class point 3D extends point. This feature you can call as here inheritance. Now in this we define one more. Now this time one more property we need to define here. Private then followed by here ZC, it is nothing but int. Integer ZC we can have here. Okay, so this one is what here, it is a ZC we have taken, Z coordinate. So extra what we require here for constructors, we go with the constructor again, public, what we put here, point 3D we put here, and in this method we need to write, we call first of all superclass constructor, followed by here write ZC equal to, write it as here some 0, even Z coordinate also 0 only. Okay, similarly we put one more constructor here, public point 3D, here write int x, int y, then int, other thing is what, z, you can put like this. So here we can call the superclass constructor first of all, that means base class constructor we can be calling here x followed by here y, then write here ZC equal to, put it as z, like this you can make it. This is what it is a this is going to be here a point 3D class. We created a new class called as point class only, but with third dimension we created it. Now next thing here, public, one more constructor this time I make, point 3D. So here I pass the parameters as point p, then other thing is here int z. Can use like this. So here in such cases now I can use this way. Super we use here, super followed by we put like p dot get x. Similarly here we write p dot get y we can use. Like this we can be invoking methods here. So this is what, therefore it is a superclass constructor. Z equal to, we put it as here, ZC equal to, we can put Z. Like this we can be making it. So this class is now what here, 3D point class, point 3D extends point. Whatever features you have in the point, they are going to be available now here. So here you require just one method. The method is what, setter as well as getter is required for the Z coordinate. So here write public, then write void set z. This is here int z we put. So we can put here z coordinate now. Here write ZC equal to, put it as z. Similarly, we can take here public, then followed by here int get z. We return here z coordinate now. So what value we can return here? Return z. Like this we can be returning this. So this is what exactly z coordinate. After this, one more method we need to override. What is that method exactly? ToString method we need to override here. Write string ToString, put like this here. What values we put in this? Here write return, it should be public. We have to make this as public, otherwise we can't access that. Return, here take super dot, use ToString, okay, we can use here 2 dot superstring, but 2 dot superstring is showing there that particular coordinate. So how we do therefore in such cases? I can do like this. Here first of all I find here int POS equal to super dot toString dot index of IUs. So index of what exactly? I can use here and I can use index of that. Okay, from here dot substring we have here starting from 0 to which position we use here. This will be POS. Up to POS we take. Then put here probably POS minus 1 we can use. Okay. We put here plus. Then here it is going to be comma z equal to, write it as plus. We try to put it as get z plus we put here, give a plus we put here, followed by we can go with the dot substring. From there we specify it as POS. So like this we can be returning here substring. Up to this brackets are required. So like this we have overloaded the given toString method. If we come to this, then try to create here a point 3D. toString. See here, values for coordinates x equal to 10, y equal to minus 2, z equal to 6, and it's lying in fourth quadrant. 0 is missing there. Reason, we are using minus 1, because of that it comes in that way. If you come to this point here, it cannot be, whenever we try to use it, position 1 we have taken, because of that it comes in such manner. If you once again run, we get exactly this time. This is run as Java application. It is saying like this now. The values for coordinates x equal to 10, y equal to minus 20, z equal to 6, and it's lying in fourth quadrant. Like this it's giving. So here we have inherited point class into another class. Is what exactly? It is point 3D. We extended point into point 3D. Then in this we added a constructor point 3D. There we are calling superclass constructor and z is equal to 0. Similarly, we created second constructor which is containing x coordinate, y coordinate and z coordinate. We called superclass constructor xy, then z is equal to z we kept. So similarly here we have written these things, set z, get z. Okay, new functionality we added there. Then here toString we overloaded, because in the case of point it is going to be just x coordinate, y coordinate, but here you require both x coordinate, y coordinate, z coordinate. So like this existing functionality I have used, with the help of that I could do this. So this is what exactly inheritance we can say. From point to point 3D we got. This feature is called as inheritance. The features available with the point class are available here also. Any questions? Okay. So we'll do further tomorrow with the abstract classes, abstract methods, then final classes we can create. With that we can work. So writing code with the OOPS is easy, but conceptualizing things is important. How you conceptualize, that is going to be really difficult task in that. Writing code can be easy, but you need to be making a picture of it in the mind, then accordingly it can be made. Any questions, Bengal?
No, Sridhar. No questions.
So we meet tomorrow then. Thank you.
Okay, Sridhar. Thank you. Bye.